World War II, Nazi Germany, as Hitler waged war and committed crimes against humanity. Arnold Eucken was publishing the thermodynamic basis for understanding Earth formation. I have confirmed and extended Eucken's calculations and connected those to other fundamental geophysical and astronomical observations. Together, these provide a new, complete theory of Earth dynamics, which I recently published in the scientific literature. This video is about that theory, called Whole-Earth Decompression Dynamics. At least as far back as 1858, Antonio Snider Pellegrini recognized that opposing margins of continents appear to fit together in certain ways as if they had been joined in the past. Early in the 20th century, Alfred Wegener proposed that the continents at one time had been united, but subsequently had separated and drifted through the ocean floor to their present positions. Wegener's theory of continental drift was vigorously opposed for half a century before being revived in the 1960s and modified to become plate tectonics theory. Plate tectonics is based upon the idea that ocean floor, continuously produced at mid-oceanic ridges, moves like a conveyor belt, ultimately plunging into the Earth and being recirculated by assumed convection currents in the mantle. Indeed, the magnetic striations on the seafloor support the idea of seafloor being continuously produced at mid-oceanic ridges, moving away from the ridges and ultimately plunging downward into the Earth. But there is a problem, a very serious problem, with the idea of mantle convection, as I show in the companion video, No Mantle Convection. When a fluid is heated from beneath, it expands, becoming lighter, less dense than the fluid above it. This top-heavy arrangement is unstable, so fluid motions result as the fluid attempts to restore stability. Not only is the Earth's mantle not a fluid, but the weight of the overburdened rock causes compression within the mantle, which increases with depth. Heating rock at the base of the mantle causes a minuscule increase in volume, hence a minuscule decrease in density. This is far, far too little to make the mantle top-heavy, and there would be problems as well posed by the heat of compression. The result is no mantle convection. No mantle convection means that plate tectonics theory is wrong, which may not be surprising, as plate tectonics is an incomplete theory that never included an energy source sufficient to power global dynamics. Textbooks rarely mention a competitive theory of global dynamics called Earth expansion theory, which predates plate tectonics, but which has its own serious problems. In 1933, Otto Hilgenberg published his idea that, in the distant past, for some unknown reason, the Earth was smaller, without ocean basins, and that subsequently the Earth expanded, as illustrated by the series of globes which he made. We now know that the surfaces of planets generally consist of complete, uniform shells of matter, except Earth, with its unique two-component surface, comprised of about 41% continental rock, with the balance being a quite different ocean floor basalt. To date, there has been no satisfactory explanation for the partial crustal continental layer, except Otto Hilgenberg's assumption that the Earth in the distant past was smaller and subsequently expanded. The principal objection to the idea of Earth expansion has been the lack of knowledge of a mechanism that could provide the huge amount of energy required without departing from the known physical laws of nature. Neither plate tectonics theory nor Earth expansion theory is an adequate description of the dynamics of the Earth as a whole. Recently, I proposed in the scientific literature a new geodynamic theory called Whole-Earth Decompression Dynamics. My theory takes into account evidence related to Earth formation and reconciles certain elements of each of those two seemingly divergent theories into one unified theory of Earth dynamics. Please join me in Part 2 for an easy-to-understand description of this fundamental new theory of global dynamics.